Okay, then we have also here, we have in the field of vaccination. So it was then Edward Jenner, considered to be the father of the vaccination, tried to advocate here for the development of the vaccine. The word vaccination came from the word vaca or cow. It's because here, the first vaccine formulated here is actually coming from that's the vaccine against the cowpox. So cowpox is a viral infection of the cow, but eventually the patient here has been exposed to the cowpox, develop here resistance against the smallpox. So nangyari nito, ang disease itself, the cowpox na virus came from the cow or the disease or the infect na cow. However, for those na kapag they get infected by the cowpox or they've been exposed to the cow with the infected the cowpox virus, they develop here resistance against the smallpox. Pwede naman yun eh. Specifically kasi pag sinabi nating vaccination, is very specific. Kung ano ang in-expose sa'yo, where you develop an antibody, dapat doon ka magkakaroon ng protection lang. So by theory dapat, since na-expose sa cowpox, you develop here an antibody dapat against the cowpox. Pero nangyari dito, since your cowpox virus and your smallpox virus belongs to the same family of the virus, the pox viruses. So pwede ka mag-develop din ng resistance even against the smallpox. Okay, so yun ang basis ng vaccination here by Edward Jenner. Na-notice kasi ni Edward Jenner for those mga milkmaids. Pag sabing milkmaids, sila yung mga nagagatas ng cows. So, since very exposed sila sa cow, nag-develop sila ng resistance dito against the cowpox na reinfection and even against the smallpox na infection. And that's become the theory of the vaccination. Kasi by principle ng vaccination natin, we're given a vaccine. Okay, ang binibigay sa'yo is not antibody ha. Pag vaccine, binibigay sa atin is the organism, the antigen. Pag binigay sa'yo, ang organism na yan or your vaccine, your body will be exposed to that organisms. And then eventually your body will develop an antibody. And that antibody serve as your protection. That's the principle of the vaccination. Pero, hindi lahat ng vaccination magiging successful. Okay? So, sometimes, pasabihin natin, ay, nagpa-vaccine naman ako, bakit nagkasakit pa din ako? But then again, maybe because you did not develop an antibody. Because again, what is being given to you is the antigen. It's up to your body to develop an antibody. That's why you still need to check later if you've developed an antibody. Once you develop antibody, that's only time you are protected against infection or even reinfection. Okay, then we have here Joseph Lister. So let's try to introduce here the use of the antiseptic phenol. Okay, so make here the basis for the antiseptic surgery. Then we have here Robert Koch. Robert Cox here tried to provide a solid proof or evidence here that a particular disease is caused here by the microorganisms. So he tried to isolate actually Bacillus anthracis. Bacillus anthracis is actually a causative agent of your anthrax. And he tried to isolate that bacteria coming from the cow. And Robert Koch also tried to be the one responsible here for isolating your Cox bacilli. It's being known here as your Mycobacterium tuberculosis, responsible for the tuberculosis. Okay, Robert Koch here actually tried to make four postulates regarding the existence of the causative agent responsible here for causing a specific disease. So we have here a microorganism here could be isolated from a dead organisms which has been infected by a disease or even those patient na infected by a disease. So pag nagkasakit tayo, Sabi niya, we can isolate the microorganism responsible for causing the disease. Again, if that organism is bacteria, so pwede ka kumuha ng sample doon sa infected na patient or dead na animal which has been infected by that disease. Kuha ka ng sample, then what you're going to do here is just isolate that one and grow it in the laboratory in a form of your culture. Kaya na nagko-culture tayo ng bacteria, di ba? So by culturing your sample and identifying and allowing the bacteria to grow in a culture media, you're able to identify that organisms. Okay, so after taking that organism here from a patient, diseased or infected patient, allow it to grow in a pure culture in the laboratory. Pag nag-grow na siya, pwede natin siyang ma-identify kung anong specific na bacteria causing the disease. The next one, sabi ni Robert Koch here, if you get a sample of that bacteria na nag-grow in your culture media and inject that one to another organism, like healthy organism. Pag in-inject mo siya, ang bacteria na nag-grow mo sa pure culture mo in a laboratory, that healthy organism here where you try to introduce or give your bacteria in pure culture in the laboratory, that organism will get infected. Magkakasakit din siya. And then eventually, pag kinuwanan mo ulit ng sample itong second mo na binigyan mo ng bacteria, same bacteria will be identified here coming from same bacteria na nag-infect sa second organism mo na healthy patient, same bacteria kung saan galing yung unang bacteria na na-isolate mo. That forms part here, the so-called here Koch's postulate. So tama naman lahat ito. Okay, then we have here in 1884, Chamberlain tried to construct here the first porcelain bacterial filter. Then we have with the first viral pathogen or virus isolated here in the form tobacco mosaic virus. Then we have here his and alshismus. So they try to suggest here the use of the agar as your solidifying agent when you are doing your culture media. And until now, diba, so our culture media sa Petri dish natin, that's made up of the agar. Again, the solidifying media provides support for you to grow your bacteria. Then we have here Richard Petri. So, siya ang gumawa ng Petri dish natin kung saan nakalagay ang ating mga culture media with your agar and supporting the growth of your bacteria. Okay, then we have here discovery highlights in the microbiology. So we have here Charles Jules Henry Nicole. So he is responsible here for identification of the vector lice or the human lice as your pediculus humanus as the vector for the transmission of your epidemic typhus. Causative agent for that is your Rickettsia prowazekii. Another one, we have Paul Ehrlichs with his salvarsan, which is the first chemotherapeutic agent for management for the treatment of the syphilis. Then Gerhard Domack with the first commercially available antibiotics in the name of sulfonamido chrysoidin with the brand name Pronostil. Then we have also Alexander Fleming with its penicillin here for the treatment of the different bacterial infection, and that's isolated here from your fungi Penicillium notatum. Then we have also Selman Waxman for the discovery of the streptomycin, which is the first drug of choice for the treatment of your tuberculosis. Okay, now we go to the different discipline in the microbiology. So we have here the phycology. Phycology is the study of the algae, including here the unicellular algae to the multicellular na mga seaweeds, which are much bigger and have a complex structure with just your plankton and your algae. Bacteriology will be studying here about your bacteria, with their metabolism, with their disease association and all. Mycology is all about your fungi, protozoa, with your protozoans, your helminths, including your amoebas. Virology, so that's a study of different viruses, and parasitology with the other parasites. Okay, then we have your other field of your microbiology. So we have microbial ecology. So microbial ecology deals here with the relationship of the microbes and the environment. Microbial systematics, the process or way of classifying, naming, and identifying the different microbial organisms. Microbial physiology um, discuss or try to tackle here regarding the metabolism of your microorganisms at the cellular and molecular level. Then microbial genetics, all about your genomes, your heredity, and your different variation, different species. Okay, then we have also here the different discipline in your microbiology. So first we have here the phycology. So phycology, again, the study of your fund of your algae, including here your seaweeds. So we consider here your algae as eukaryotic organisms. Bacteriology, bacteria are prokaryotic organisms. So we have here hydroxyls here try to identify the presence of a very big bacteria that is capable to be seen by our naked eye in the form of your Thiomargarita namibiensis. Another bacteria was then isolated here from the Titanic na ship na nag-sink. Okay, they identified the bacteria here as an iron oxide consuming bacteria as Halomonas titanicae. Halophiles are mga salt-loving na mga organisms. That's why nasa sea kasi siya. Mycology, the fungi are considered to be eukaryotic organisms with their implications, with their importance, and medical fungi and all of that one. Protozoology here, single-celled but still eukaryotic organism pa din sila. Virology, so those are inert organisms, mean to say they are alive once they are inside the body of the host, but outside that one they are not. Okay, so we classify your viruses here according to their nucleotides. Some viruses are DNA, the viruses, others are RNA. Then we could also classify their nucleotides as single-stranded or double-stranded. Pwede siyang single-stranded RNA, double-stranded RNA. May mga viruses naman na single-stranded DNA, may mga double-stranded DNA. Another one, they're also classified here for the presence of either envelope. So pag ang kanilang membrane may naka-cover pa, so they are envelope. Kung wala naman, they are classified as a naked na viruses. Anyway, you'll be discussing that one in your virology naman. Parasitology, so we'll be discussing here. Parasitology is all about your parasites, the bigger one. In 2011, there was then identified na parasite found here in the inner core of the earth. So they call it once your devil worm, and that's Halicephalobus mephisto. Okay, then we go now to the benefits and the harmful effects of your bacteria. So we have your beneficial effects of your microorganisms. So again, they're used here for your dairy products production, including your cheese and your yogurt. Useful also in the leather industry. So we also here the so-called nitrogen fixing bacteria. Your nitrogen-fixing bacteria try to fix nitrogen from the atmosphere, converting that one to your ammonia. And ammonia is needed by the soil in order for that to become fertile. Then we have here the probiotics, are live microorganism here which provides benefits to the host. So like for example, we have your Lactobacillus shirota strain, your Bifidobacterium, and we have your normal microbiota or organisms here normally found in the different part of your body. Like in your skin, may normal microbiota tayo. Anyway, we'll just be discussing it naman in details when we go with that different bacteria. Another one, so microorganism here also used for the preparation of antibiotics. Like for example, your penicillin from your Penicillium notatum. We have several antibiotics are all derived from the microorganisms. Okay, now we go to the harmful effects. So the first one, we have here the animal pathogens. So we have several bacteria which try to cause here infection in the human and even in animals. In your PowerPoint, there are so many of that. So kindly go through na lang. So example for that, we have your Mycobacterium tuberculosis try to cause here tuberculosis. Salmonella typhosa which try to cause here typhoid fever. Clostridium tetani try to cause here tetanus. Shigella dysentery try to cause dysentery. This is your diarrhea. Haemophilus influenzae try to cause here influenza. Clostridium, no, this is your Corynebacterium diphtheria try to cause here diphtheria. And again, there are many others diseases listed in your PowerPoint. Again, we just need to go through with that as we go with individual na mga bacteria naman. Okay, then we have here some of your microorganism here are plant pathogens. So among the plant, it try to cause here damage, it try to cause rotting of your plants. Like for example, we have your Xanthonionas citri. So basically, try to affect here mga citrus fruits natin, try to cause damage on those type of the plants. Food destroying bacteria, like for example, your Staphylococcus, or even your Clostridium botulinum here. Clostridium botulinum here try to cause food poisoning. Then we have here soil fertility destroying bacteria to try to reduce the fertility of the soil. Example for that, we have your Bacillus denitrificans. From the word itself, denitrificans, try to remove the nitrogen. So it reduces the nitrates and ammonia. Okay, try to break it down in allowing here nitrogen to be free. So it's try to remove here the nitrogen. The nitrogen we're going to escape to the air. And it would deprive here your soil with the ammonia content, which is one of the component of the soil here to make it fertile. So, thank you.